And so when I structured this talk, I structured it more around the kind of core ideas in Servant. They do come out of the paper. The paper is totally readable. I encourage you to read it. I'm going to focus more on the project. I think that'll be a little bit easier. If you're curious, I gave a longer version of this talk a couple years ago, and it has a lot of code, and the code all compiles. This is all in Haskell. So if you want to, you can clone that, and you can run it yourself. So I started working with Haskell a few years ago, probably a few years ago. And I started becoming interested in, now that I'm working with this language, I wonder if there are web frameworks. And I heard that there were some web frameworks that were difficult and others that were a little more easy to use. And I thought, I don't want the difficult ones. It's already a friggin' hard language to use. And one of the difficult ones is this library called Servant. So I was like, I'm not going to look at that. A little bit after that, I heard there was a paper. And I was like, why would you need a paper for a web framework? What the hell is that about? And the paper's called Type-Level Web APIs with Servant. And I found it to be, and so I didn't get interested in the project until I read the paper. And I was like, wow, this is kind of a cool idea. Here's a comment from a line from the paper. By turning the API into a Haskell type and thereby into a first-class citizen of the language, we gain the ability to perform many operations on the API while statically checking that all our applications are in fact conforming to the desired API and consistent with each other. I'm sure that makes tons of sense. It's really self-evident what that means. So we're gonna, this is kind of the whole idea that I wanted to unpack. There are some other interesting ideas in the paper which I didn't really have time to talk about now, but I would encourage you to check it out. So these are core ideas of Servant. The Haskell is a statically typed language. People who work in Haskell work very hard to render their business logic, their problems into types, and then they work with those types. So they're very serious about representing everything in types. So the idea for Servant was, well, let's take a whole, like a web application, I call it an API in the paper, and we'll just build a type, a Haskell type that represents that API. And then once we have that type, we're going to interpret it. So we will build the type representation, and then we will build interpretations. And this actually leads to some interesting stuff. We can interpret it in a lot of different ways. There's a quick and dirty little bit of syntax. I assume that nobody has ever seen Haskell before. You may have. Obviously, this is very, very quick, but these are type declarations in Haskell. Type declarations are usually separate from. You can put it inside, but this is a function definition, and this is the declaration as type. This is a function that takes an integer and returns a bool. There's the argument. There's the actual function definition. You can declare aliases for types. Anywhere you declare an alias like this, you can either pass that thing or the thing that it's an alias for. You can also declare things that are called new types. Rust has something like this, I think. But anywhere that takes an int, I can't pass this counter thing, although once it's compiled down, all the types are erased, and this actually is represented as a real int. So there's no penalty for declaring this, but it enables me to say, this function doesn't take an int. It only takes this thing. And if you want to call this function, you must construct one of these in order then to call the function. And I threw in quicksort there because people always like that. See how short it is? That's what the test is going to be on that. You got to reconstruct that. Okay, so what does describing a web API as a type look like? It's actually at the bottom. There's some kind of necessary stuff at the top, which I can go into. I've got this thing, this counter thing. It's really just an integer. I'm telling the compiler, hey, I want to be able to represent this as JSON. I want to be able to interpret it as JSON and send it back as JSON. That's what these do. And really what you're going to end up with is a JSON record that has, it kind of like looks how you would expect. It's got curly braces, the key is value, and it's going to have an int as a value. So this is the actual description of the API. There's 3 endpoints here. This operator is kind of like an or alternative. This API is this or this or this. And so there's this interesting language which is actually described in the paper to talk about things like HTTP methods as verbs, to talk about content types, and to talk about like captures and request body arguments and headers. All of this stuff is represented. This is a type. So you can't pass this thing to a function. You can only sort of represent it as a type. Just to belabor this a little more, this is an endpoint that starts with this, has a slash, and then an integer. And when you post with content type JSON, you'll get back some kind of counter representation. So that's what it looks like to describe a web API as a type. Now, once you have this description, that's where you get to the interpretation part. So what kind of interpretations can we generate? Well, one of the interesting things is we can generate clients, applications that make requests of these things. So to generate a client in Servant, all I have to do is import this Servant client library, call the client function on a representation of my API. That's this kind of proxy thing. It's saying, I don't have a real thing. I'm going to fake it. I'm going to give you a proxy to it, and you'll get 3 functions back out. You got 3 endpoints, you get 3 functions back out. So that's all that I need to do in order to generate clients to query this API. To actually run this, looks like this. The interesting thing about these functions, you can't make incorrectly typed requests using these client functions because it won't compile. So that one takes a counter argument. You have to give it a counter to be able to call it. This one takes an int. You have to give it an int to call it. This one takes no arguments. If you give it arguments, it's not going to compile. So these are just some examples, and then I actually built a program that compiles so you can kind of see. What other interpretations? Well, the most common way to interpret one of these things is to build a server. You're going to build a web application, maybe some JSON serving API. That's a little more involved. You can't just call a function that says server and magically get a server back out. You do have to define handlers. So you define this kind of server thing, and then you say, well, this is a handler, and this is a handler, and this is the handler. Notice this operator shows up again. It's, that first endpoint, this handler, second endpoint, this handler, third endpoint, this handler. And again, I have the API representation down here. This is duplicated from before. This is one example of one of these handlers. They also are going to take the same types. So this reset takes a counter as an argument and returns a counter. Now I kind of defined it so that it takes an extra special argument to make it easier to do the kind of business logic. Now that may sound like you're doing a bunch of work to kind of get something that isn't that interesting. I find it interesting because there are lots of other interpretations. So if you've heard of like Swagger CodeGen, Open API, this is like in the same vein. You can define a Servant API, define one of these type level things. You can automatically generate documentation for it. It doesn't have to be a server that you're gonna run yourself. You may want to just magically generate documentation. You can do that with Servant in a pretty straightforward way. You can actually generate client code in a myriad array of languages. There's Angular generators, jQuery, React, plain JavaScript. There's a Python one. I wrote the Python one, fair warning. There's a program called Servant Quick Check where you can actually have an API spec and you can say, Quick Check, go out and check. There's 2 different servers. Like I'm deprecating this one, I'm spinning this one up. Quick Check, make sure that they're the same. When you make a request to this one, make the same request to this one. And if they're not the same, tell me about it. That's a failing test. So this is kind of what I find exciting about Servant. You build an API as a type in Haskell, and you can generate all kinds of interpretations out of that type. And that's it. I don't know how I did in time.